Welcome back, Pre-Calc. Hope you all are well. Our objective today is going to be to solve polynomial inequalities both by hand and graphically. I've got the checklist on the screen. You know what to do from here. So in calculus, we solve polynomial inequalities to reveal certain aspects of functions. So for example, after doing the steps of calculus, we may need to know where a function like this is positive or negative without looking at the graph. Okay, so what I want to do first is look at the graph and talk about what it means for a function to be positive or negative, and then see if we can solve these types of questions without looking at the graph. But the first thing I want to do before we look at the graph is actually find the zeros, or the x-intercepts of this function. So I'm going to go ahead and force a pause on your screen. Can you copy f of x in your notes for me? Okay, we are back. So to find the zeros, notice it's already factored for us. So let's look at this first factor. This factor is going to be 0 when x is negative 3/5, right? If I set this equal to 0, I would need to subtract 3, divide by 5. All right, that second factor is going to be 0 when x is 2. And then that last factor is going to be 0 when x is negative 4. So I've got 3 real zeros, so 3 x-intercepts. Now let's also talk about the multiplicity. So the multiplicity of this first factor is even or odd? It is even. It's a multiplicity of 2. So does that mean that the function is going to cross or not cross at negative 3/5? It is not going to cross. Okay, what about the factor of x minus 2? Multiplicity even or odd? It is odd because it's it is an understood exponent of 1 here, and 1 is odd. So cross or not cross at 2? Cross. And what about multiplicity at of this factor? It's an understood 1 as well. So we cross or not cross at negative 4? We will cross. All right, let's take a look at the graph. All right, so here's our function. Notice that we do have x-intercepts at negative 4, at negative 3/5, and at 2, and we cross at negative 4 and 2, but not at negative 3/5 again, because we had even multiplicity associated with that factor. All right, so now let's really talk about where this function's positive, where it's negative. Now, when we talk about a function being positive, I'm not talking about increasing, decreasing, okay? I'm talking about, are the y values positive or negative? So let's break these up into our 4 intervals. So we have 3 x-intercepts, we have like these 4 intervals to check, right? So let's take a look at that first interval, so going from negative infinity to negative 4. So I am looking at this section right here. Are those y values all positive or negative? All those y values are positive. You're sitting above the x-axis, so positive y values here. Okay, now let's look at your next interval from x equals negative 4 to negative 3/5. Do we have positive or negative y values here? All these y values are negative, so you're sitting below the x-axis, right? And again, not increasing, decreasing, just are we above the x-axis, positive, or below the x-axis, negative y values? All right, what about that next interval from negative 3/5 to 2? Positive y values or negative? Negative y values. And then that last interval from 2 to infinity, positive y values or negative? Those will be positive again. All right, force pause on your screen. Can you do me a favor? And I'm just going to bring down the x-axis here. Can you copy just the number line I have? So just give me a number line with those 3 x-intercepts for me. All right, so now let's denote our number line to depict what we got from the graph. So our y values went from positive, negative on this interval, right? Negative on the next interval, and then positive again, okay? And, why does it not, the only time we didn't change signs, like we went yellow, green, and went green, green, and then we switched again, green, yellow, we only did not switch at negative 3/5, and keep in mind that's because of the even multiplicity here, right? Because no matter what value I plug in for x, this term is never going to be negative, right? But if I take a factor that has an odd degree, like if I plug in 0 for x, this term is negative, but if I plug in 3 for x, this term is positive. So those terms have the ability to switch signs, and if they can become negative, then they can switch the sign of the entire expression, okay? So that's why with even multiplicities, you're not going to get that sign switch, okay? All right, now the question is, well, what if we didn't have the graph, right? What if I just gave you the function? Well, here's what I want you to write. Can you write n equals, and n is your degree, and then LC equals, and that's your leading coefficient, okay? So let's take a look at the degree. It's already in factored form, so all I need to do is count up my exponents as long as I think about these understood exponents of 1. So 2 plus 1 plus 1 is 4, which is even or odd? Even. And then my leading coefficient, I don't need to know the number, but I do need to know the sign. I don't see any negatives out in front of these factors here. So my leading coefficient is going to be positive, right? So my end behavior is going, both my tail ends will be going up. All right, so now what I can do is, okay, well, if I know my tail end is going up here, my y values must be positive to start out with. Okay, so this tail end here tells me, oh, I'm starting with positives, right? Because if this is my x-axis and y-axis, a tail end going up, y's are positive. Okay, now if we come to -4, I can look at the factor there and say, oh, that multiplicity is odd, so I know I must switch signs. So I went positive and then switch to negative. Okay, now I'm at -3/5. Well, let's come to that associated factor, even multiplicity, so that means no switch, right? Okay, so I'm going to start at, it was negative, going to keep negative at -3/5. All right, now I'm at 2. So I'm going to come to that factor. Okay, that had odd multiplicity, so odd, oh opposite, so switch signs again. So I was at negative, and then at 2 I need to switch to positive. And I can look, oh, well, that's good news because my tail end on the right-hand side should be going up as well, so I should end up with positive y values there. If you're feeling a bit shaky about how to use kind of the end behavior and the multiplicity to get your sign chart, you can always just literally test an x value in an interval. So like if I want to take a look at this interval here and figure out the sign there, pick any x value. Like a convenient one would be 0, right? 0 is between -3/5 and 2. So if I plug in 0 to the original, I get 5 times 0 plus 3 squared, and then I get 0 minus 2 to the -1 times 0 plus 4. Okay, and I can tell that's a positive times a negative times a positive. Yes, this is going to be negative, and that would be the case for any number you picked in that interval. All right, force a pause on your screen. Can you please copy the inequality for me? All right, so let's try this without, let's make our number line without looking at the graph, and then we'll look at the graph and make sure we were correct. So first step I want you to do, this one's not factored, so let's go ahead and factor. Always look to see, is there a GCF you can factor out? And in this case, yes, I can factor out a common factor of x, which leaves me with x squared minus 4x plus 4. I'm going to leave off the inequality for now. I can factor that trinomial some more, so that would be x minus 2, or x minus 2 quantity squared, okay? Let's set this equal to 0 and find our real zeros. So that first factor is just x, so this will have an associated 0 of just 0. And then the second factor of x minus 2 has a 0 of 2, right? So just those two numbers to put on our number line. So that's what we're going to do next. Let's make a number line and only put the values you got up here on the number line. So and make sure they're in order. So I got 0 and 2. All right, so now let's talk about what this graph looks like. So what is your degree? Well, your largest exponent is 3, and your leading coefficient is an understood positive 1, okay? So my tail ends go down and then up with odd degree positive leading coefficient, right? So if they start with a negative here, then, or going down, this must be negative here. All right, now I'm at 0, so come back, take a look. 0 came from this factor, which has even or odd multiplicity? Odd multiplicity. So should I change to positive or stay on negative? I should change to positive, right? So I'm going to have positive here. All right, now I run into x equals 2. So go look at the multiplicity. Was it even or odd? It was even. So should I switch to negative or stay on positive? I should stay on positive because we don't cross, we don't switch at even multiplicities, okay? All right, so we want to come back to this inequality. We want to know where this inequality is less than 0. Was less than 0 positive or negative? That is negative, so that is going to be this interval here, right? So in interval notation, that's negative infinity to 0. Would you want to include the 0, so bracket or parenthesis? Parenthesis in this case because we wanted it to be strictly less than 0, not less than or equal to. Okay, so I'd put parenthesis. All right, let's take a look at the graph. So here is the graph. We want to know when this function is negative, meaning below the x-axis, right? So that is going to be, if I can grab the correct color, that is going to be right here. And the domain of that green piece is indeed negative infinity to 0. All right, force pause on your screen. Can you go ahead and copy this? And then can you also factor it as far as it will go for me? All right, so here's what I got for the factored form. So let's find our zeros now. So let's look at this factor. This factor is 0 when x is 0. And then the second factor is 0, maybe, when x is 3. So what's the next step? Okay, now we're going to make our number line. And make sure you are only putting the values you got here on your number line. Sometimes people will put 0 on it no matter what. Don't do that. Only put 0 on your number line if it is indeed one of your solutions from this step. Okay, so now let's talk about the degree and the leading coefficient of my initial polynomial. Well, the degree was what? The degree was 3. And the leading coefficient is positive. So that means that, again, I'm going to have end behavior like this, right? Okay, so that means if it's going down, then I should start with a negative here. All right, okay, so we need that first interval, right? And then I am at 0, so now I can go and to figure out what happens in between the tail ends is look at your multiplicity, okay? So when x is 0, came from this factor, that has even multiplicity or odd? Odd, it understood exponent of 1, and so should we stay negative or switch to positive? Switch, right? Oh, opposite. Oh, odd. All right, now we're at 3. 3 came from this factor. What's the multiplicity there, even or odd? Even. So should we stay positive or switch to negative? Well, stay positive, right? Because even, we do not cross the x-axis. All right, so now I want to know where this polynomial is greater than or equal to 0. So would that be positive or negative? That'll be positive. So actually all of that, right? And so my final answer is parenthesis or bracket with the 0. Bracket because of the equal to symbol here, right? So bracket 0, and then it's going to go all the way to infinity, right? So let's check with the graph here. So here is my graph. I wanted to know where the y values were greater than or equal to 0. So that is going to be here. And let me draw this better. Here, I don't know why I switched to green though. Okay, so from 0 and then all the way on. All right, you all, that's what I have for you today. I will see you next time.